There is something you have never been able to stop. Something that moves through your life, whether you welcome it or resist it. Something that science still cannot fully explain. Time. You feel it right now. The slow drift of a quiet evening. The way this moment is already becoming the past. But what if I told you that everything you believe about time is only partially true? That time is not a river flowing steadily forward, but something far stranger. Something that bends, that stretches, that may not even exist in the way you think it does. Tonight, let's slow down and think about time itself. For most of human history, time was simple. It passed. The sun rose and set. Seasons changed. People grew old. Isaac Newton, the great architect of classical physics, described time as absolute, a universal clock ticking at the same rate for everyone, everywhere. Whether you were standing still or moving, whether you were on Earth or drifting through empty space, time was the same. That turned out to be wrong. In 1905, a young patent clerk in Switzerland named Albert Einstein published a paper that quietly dismantled Newton's universe. Einstein showed that time is not absolute. It is relative, and it does something no one had seriously imagined before. It slows down. The faster you move through space, the slower you move through time. This is not a metaphor. It is not a feeling. It is a measurable, testable, confirmed physical fact called time dilation. Here is a way to feel this in your imagination. Picture two twins. One stays on Earth. The other boards a spacecraft and travels at a significant fraction of the speed of light, say 90%. She travels for what feels to her like 5 years, then returns home. When she lands, her twin brother is not 5 years older. He is decades older. She has barely aged. She did not experience those years, because for her, moving so fast through space, time itself ran more slowly. This is not science fiction. Satellites orbiting Earth move fast enough that their onboard clocks tick slightly slower than clocks on the ground. Engineers must correct for this every single day. Otherwise, GPS systems would drift by kilometers within hours. Time dilation is not a curiosity. It is built into the technology in your pocket. But speed is only part of the story. Gravity does something to time as well. Einstein's later work, his general theory of relativity, showed that massive objects warp the fabric of space and time around them. The stronger the gravity, the slower time flows. This means that time passes very slightly faster on a mountaintop than at sea level. The atoms in your head, sitting a little higher off the ground than the atoms in your feet, are aging, just barely, imperceptibly faster. Near a black hole, this effect becomes extreme. At the edge of a black hole's gravitational pull, time slows to a crawl compared to the universe outside. An observer hovering near that boundary would watch the entire future of the universe play out in what feels to them like a short time. Time does not stop, but it stretches almost beyond recognition, so time is flexible. It bends with speed and gravity. But here is the question that has puzzled physicists and philosophers for over a century. Why does time only go in one direction? The laws of physics, at their deepest level, are almost entirely symmetric in time. The equations that describe how particles interact work just as well running forward as they do running backward. If you filmed two electrons colliding and played the footage in reverse, both versions would look physically valid. Nothing in the fundamental mathematics of the universe insists that time must move forward, and yet it does. Always forward, never back. Scientists call this the arrow of time, and it is one of the deepest unsolved problems in physics. The leading explanation involves entropy, the tendency of systems to move from order toward disorder. A dropped glass shatters. A shattered glass does not reassemble itself. Heat flows from hot objects to cold ones, never the reverse. The universe is slowly, steadily, irreversibly spreading out, and it is this spreading, this drift toward disorder, that gives time its direction. We live at a moment in the universe's history when things are still relatively ordered. Stars are still burning. Galaxies are still forming. And so time still has somewhere to go forward. Toward greater disorder, toward a distant future the universe is always becoming. But here is the thought that is perhaps the strangest of all. Some physicists believe that time, as a fundamental feature of reality, may not exist at all. In certain approaches to quantum gravity, the equations that describe the deepest structure of the universe contain no time variable. Time does not appear. It is not built in. Instead, what we experience as the flow of time may be something that emerges not from the universe itself, but from the way we, as conscious observers, experience change in memory and causality. Time, on this view, is something like temperature. Temperature is not a fundamental property of a single particle. It emerges from the collective behavior of many particles. Perhaps time is similar, not woven into the fabric of reality, but arising from it. We do not yet know if this is true. It may never be fully resolved. What we do know is this: the time you feel passing tonight, the quiet weight of this moment is real. It is yours. And even if its deepest nature remains a mystery, it is also, in some sense, everything. Every memory you have, every person you love, every experience that has shaped you, all of it lives inside time. Whatever time truly is, it has carried you here, to this moment, to this breath, and that, perhaps, is enough. Sleep well.